If we plug this into the equation, we will get -1. And because this is negative, the kangaroos will never meet. Have you ever been asked to coordinate circus animals for your job interview? No? Well, as I'll show you, that's one of the likely questions you'll be faced with if you're doing coding interviews on HackerRank. Alright, picture this. We're at a circus and we have two kangaroos along a numbered line. Kangaroo 1 starts at position x1 and jumps at v1 meters per second. Kangaroo 2 starts at position x2 and jumps v2 meters per second. Our task is now to figure out, given these input parameters, if the kangaroos will ever land on the same spot. If they do, we return yes, otherwise we return no. Let's dive into it with an example. Let's say that Kangaroo 1 starts at position 0 and jumps 3 meters per second, while Kangaroo 2 starts at position 4 and jumps 2 meters per second. So in this case, we can say that the kangaroo number 1 is going to land on position 0, 3, 6, 9, and 12, while kangaroo number 2 is going to land on position 4, 6, 8, 10, and 12. So they'll both meet after 4 jumps. So in this case, we would print yes. But how can we determine this for any starting position and any jump speed? Let's take a look at the math. To solve this problem programmatically, we'll have to derive a simple formula for the scenario. Let's say that after n jumps, the position of the kangaroos are equal. To write this, we take the starting position of kangaroo number 1, x1, and add it to the speed it jumps at times the number of jumps, so n times v1. We write the same on the other side of the equation for kangaroo number 2. By rearranging this, we get this simple fraction to calculate n. If n is 0 or above, the kangaroos will meet at some point. If n is negative, they will never meet. Alright, enough equations. Let's get into the code. So from the formula, we can see that if kangaroo 2 starts ahead of kangaroo 1 and jumps further than kangaroo 1 at every jump, they will never meet. Makes sense. Let's look at an example. Let's say that kangaroo number 1 starts at 3 and jumps 2 meters per second, while kangaroo number 2 starts at 4 and jumps 3 meters per second. If we plug this into the equation, we will get -1. And because this is negative, the kangaroos will never meet. To write this in code, we'll simply create a conditional where we check the two parts of the fraction. We'll therefore write in our conditional that if the starting position of kangaroo 1, x1, is less than the starting position of kangaroo 2, x2, and the speed that kangaroo 1 jumps at, v1, is less than or equal to the speed that kangaroo 2 jumps at, v2, then we'll return no. Next, we need a condition for when they do meet. What we want to check is that the difference between the starting position of the two kangaroos is evenly divisible by the difference in their speed. This is just a mathematical way of saying that if the difference in starting gap can be exactly covered by how much faster one kangaroo jumps over the other, they will meet at some point. In Python, we can check if the difference in starting position is evenly divisible by the difference in speed by using the modulo operator. If the modulo operation between the difference in starting position and the difference in speed returns 0, it means that it's evenly divisible. In other words, there's no remainder. So in the code, we'll write another conditional. So elif the difference in starting position x1 minus x2 modulo the difference in speed v2 minus v1 is equal to 0, we return yes. Now we're just missing one last case. In the case that kangaroo 1 starts behind kangaroo number 2 and jumps faster than kangaroo number 2, but this faster speed does not allow it to land on the exact same spot as kangaroo 2, neither of these conditions will be true. Let's look at an example. Let's say that kangaroo 1 starts at 0 and jumps 4 meters per second, while kangaroo 2 starts at 5, jumping 2 meters per second. After the first jump, kangaroo 1 will be at 4, while kangaroo 2 will be at 7. After the second jump, kangaroo 1 will be at 8, while kangaroo 2 will be at 9. After the third jump, kangaroo 1 will be at 12, while kangaroo 2 will be at 11. As we can see, the kangaroos will never land on the same spot again. Kangaroo 1 will always be ahead. Now in the code, the first if condition fails to catch this as it checks if the speed of kangaroo 1 is less than or equal to the speed of kangaroo 2. Now to cover this last case, we could write an extra condition to check. However, seeing as it's the last case, we can also simply just return no after all the cases. This saves us a lot of trouble of writing an extra case, as in any other cases than the two we've written, kangaroo 1 will always be ahead of kangaroo 2, meaning they will never meet. And finally, let's see if our code is correct by running all the tests. As we can see, they're all green. So let's recap what we did. First, we check if kangaroo 2 starts ahead of kangaroo 1 and jumps faster than kangaroo 1. If that's the case, they will never meet, so we return no. Secondly, we check if the difference in starting position is evenly divisible by the difference in speed between the two kangaroos. If that's the case, they will land on the same spot at some point, so we return yes. Finally, if neither of these conditions are met, it means the Kangaroo 1 is behind and faster than Kangaroo 2. But this extra speed does not allow it to land on exactly the same spot as Kangaroo 2, so we return no. And there we go. We've solved another problem on HackerRank using conditionals to check if two kangaroos will ever land on the same spot given a few input parameters. Let me know what you think about this solution in the comments below, and if you've enjoyed this video, please give it a thumbs up, subscribe, and hit the bell icon for more coding walkthroughs. Thanks for watching, and as always, happy coding!